Alright, here we go. Ready? Brief introduction, quick introduction to sex-linked traits. So far, every trait that we've been talking about has been found on what we call the autosomes. So how many chromosomes do you have?
26 or 46.
Yeah, 46, 2 pairs of 23. So these autosomes go up to the 22nd pair. Now remember, one of these came from mom, one of these came from dad. Okay? So this is where we're getting our alleles from. There's one allele on one side, there's one allele on the other. The 23rd pair is different. In males, it's XY. In females, it's XX. Okay? This is crucial. Males are said to be hemizygous because they only have an X. They don't have two X's. So when we are following a trait like color blindness, it's found on the X chromosome. Males only have one. The Y does not have the same traits. So, for instance, let's say color blindness. To be colorblind, it's a recessive trait. You have to have a two lowercase b's to get it. So for a female, right, she's not colorblind, nor is she, right? The only way for a female to be colorblind is to be X little b, X little b. Notice, I'm taking our alleles and I'm now putting them on the X chromosome, like an X button. And that's because we have to know if this person's a boy or a girl because it changes everything. For a male, uh-oh, I can't write another letter, can I? So he is either X big BY or he's X little by. So he's not colorblind, he is. Okay? So males, I am so sorry to tell you, but you have a much greater chance of inheriting a sex-linked disorder. Females have 2 chances to get a good gene. You have 1. Okay? So let's do a cross. Let's say we have a colorblind dad, and he's married to a woman who is actually heterozygous for the trait. We would call her a carrier because she doesn't know she has a colorblindness trait in her genes, but she's heterozygous, so she carries it. So dad, his genotype is X little by. Mom's is X big B, X little b. She has no idea she has the little b unless she's paid attention to her grandparents. Okay? So when we cross them, here's what we get. So what are the chances that this family has a colorblind child? 50% chance that they're a colorblind child. Of their offspring, what are the chances that they have a female who is colorblind?
25%.
25%. It's all on how you phrase it, right? This child has one, or this family has one child who's colorblind. What are the chances that their next child will be colorblind?
Still 50%.
Right. Still 50%, because remember, past occurrences don't impact future. That's why we toss pennies.
Well, I was wondering about that. So when the parents each give an allele, right? So does that mean they get another one back somehow, or what?
When the sex cells are made, they get the same set of DNA.
Okay.
And that just gets split up.
Okay.
So actually, technically, could it impact things because it's been created and lost? Yeah, maybe.
Okay.
But it's a very small change. Very small. That is my rough, quick and dirty intro to sex-linked traits. The confusing part is knowing when to use XXXY and when not to. Only when you have something that's considered sex-linked do you have to actually follow the gender of the individual. You could follow the gender of the individual for a regular trait, only it just would look weird. You would basically be figuring out if it's a boy or a girl at the same time. So don't do that. It's a way confusing. Good? Okay.